Okay, now we are going to look into graphing just linear functions, and then we'll go on to graphing quadratic functions. So an absolute value function is a function that involves the absolute value of a variable. We have varying points. These are points that remain unchanged. And a piecewise function there talks about both parts of the graph. I'll make sure to do these in different colors so it's easier to see. We will always sketch the original first, and then we will reflect whatever is left. So if we are graphing this one first, we need to look at how we graph a linear, right? Like, we should know how to do that, but it's always good to have a refresher. So I like the x-intercept, y-intercept method, or y-intercept and then using your slope. But in this case, we want an x-intercept so we know at what point we're reflecting. So let's look at this. We have y is equal to 2x minus 3. We know our y-intercept is -3, and our x-intercept is 3/2, or 1.5. So let's graph that. Okay, we can see here that I have the original graph presented, but now we need to reflect the guy that's happening below here. So kind of remembering here, everything below here needs to be reflected up. So instead of -3 here, it should be +3. And then we know going up from this point that we would go down 2 over 1, so we'd have another point here, up 2 over 1, up 2 over 1. Now that we have that reflected, we can see that we have our line right here where it measures up very nicely. And now we can answer our questions. Our domain, XER, our range, y must be greater than or equal to 0. So, y must be greater than or equal to 0, such that y is an element of the real numbers. A piecewise function. So we have the piecewise function that is either negative or positive, or the original. So we go y is equal to. We have our original function, which is 2x minus 3, and now we have negative 2x minus 3. So this function in black, so this is 2x minus 3. This exists at this invariant point onwards this way. So it is such that if x is greater than or equal to 1.5, this one exists at the invariant point going left. So if x is less than 1.5, that is the piecewise function. Our invariant point is x is equal to 1.5. Okay, let's try that with the next one. So this should be y is equal to the absolute value of -1/2 x plus 1. So our x-intercept, our y-intercept is 1, x-intercept is 2. So let's graph this. So we can see the regular function there. Now we need to start reflecting. So if we look at this guy down here should come up here. So then up 1 over 2, up 1 over 2, and we get 2 lovely points right there. So we draw our line, and we have our function. So basically, again, here's our stop point, and everything below it doesn't matter anymore. We kind of get rid of it. So domain and range are the same as before. Our piecewise function is really what I want to focus on. So let's go piecewise function, y is equal to our original function, which is -1/2 x plus 1. And now that is on this side. So this guy exists up to this point. So he goes this way. if x is less than or equal to 2, and then our negative function, and this makes sense when we look at it linearly, because in my original one, my slope was negative, so it was decreasing, but now my slope is positive if I FOIL this out. Therefore, my slope is now increasing. So this guy exists from the invariant point onwards this way. So if x is greater than 2. Last one. Y is equal to the absolute value of negative 2x plus 3. So, our y-intercept is equal to 3, and our x is equal to 1.5. Okay, I'm going to graph this. Okay, we can see that this is now graphed, and now we need to reflect it, our invariant point being here. So then this guy comes up, and then up 2 over 1, up 2 over 1, up 2 over 1. Okay, and then draw a nice line through it. Bam. So we can see how that reflects. State the domain and range, same as before, the piecewise function. Y is equal to negative 2x plus 3. So that's the original one that exists up to this point. So if x is less than or equal to 1.5, and our negative of it, so now the positive slope, I'm going to write that in red actually. Just for consistency's sake, if x is greater than 1.5. So we did focus a lot on the piecewise functions because I think it's important that we understand it. So head off onto the assignment and let me know if you have any issues.